Hi, this is Alex from devstories.eu. GitHub Actions, episode 14 of 14. A user downloads your compiled command line tool from a release page. If a compromised dependency or a malicious actor swapped that binary after it was built, a standard checksum check will not save them. Standard hashes only prove the file they downloaded matches the file hosted, not where it actually came from. To guarantee a file was generated by your exact code, you need supply chain integrity with attestations. An attestation is not just a build log or a text file containing a hash sitting next to your release. It is a cryptographically signed, unfalsifiable claim about the provenance of an artifact. It binds your final binary directly to the exact commit SHA, the specific workflow run, and the OpenID Connect identity of the build environment. The process happens entirely within your GitHub Actions workflow. After your code compiles, you use the official build provenance action. This action calculates the checksum of your finished artifact and contacts a centralized signing authority, specifically SigStore. The workflow exchanges its temporary job-specific OpenID Connect token for a short-lived signing certificate. Because this token is minted by GitHub Actions and mapped directly to your repository, it acts as an unforgeable identity card for the workflow runner. This interaction generates a permanent cryptographic record. This record states unequivocally that this exact file hash was produced by your repository, triggered by a specific commit during a specific workflow run. The signature is attached to the artifact, creating a bundle of proof that travels with the file wherever it gets hosted. Here is the key insight. The real security value happens on the consumer side. When a user downloads your command line tool, they do not have to blindly trust the hosting provider or the download mirror. Before they execute the binary, they use the GitHub CLI to verify the attestation locally. They run an attestation verify command against the downloaded executable, explicitly specifying your repository owner as the expected source. The CLI inspects the cryptographic signature and checks it against the public transparency log. If the signature is valid, it mathematically proves the file was compiled by your official workflow. If a malicious actor intercepted the download, tampered with the compilation, or replaced the binary on the release page, the verification fails instantly. The signature cannot be forged because the attacker can never possess the temporary OpenID Connect token generated inside your secure workflow run. The identity is inextricably linked to the GitHub Actions infrastructure at the exact moment of the build. This mechanism closes a critical gap in software supply chain security. You are no longer asking users to trust where a file lives. Instead, the artifact becomes self-authenticating. Attestations shift your security model from trusting where a file lives to mathematically proving where it was born. Since this is the final episode of our GitHub Actions series, I strongly encourage you to get hands-on and start building these workflows yourself. Visit devstories.eu to suggest topics you want to see covered in our future series. That is all for this one. Thanks for listening and keep building.